Ever find yourself wondering how a bullet works? It's not just a simple piece of metal. In fact, it's a meticulously crafted piece of engineering, with each part playing a critical role. From the outer casing to the inner gunpowder, from the tiny primer to the leaden projectile, every element works in harmony to achieve its purpose. Intrigued yet? Well, you should be, because there's a lot more to learn. Stay tuned as we delve deeper into the fascinating world of bullets. A bullet, while small, houses a complex design and multiple parts. Think of it as a miniature engineering marvel that's been refined over centuries of gunsmithing. Let's break down this intricate entity. Firstly, we have the casing, also known as the shell. This is the container that holds all the other components of the bullet. It's typically made of brass, but you might also come across ones made from steel or even aluminum. The casing is more than just a container. It also serves as a seal, ensuring that the high-pressure gases produced when the gunpowder burns don't escape backwards and damage the gun. Then, at the base of the casing, you'll find a small, yet very significant component: the primer. The primer is the spark plug of the bullet. When struck by the firing pin of the gun, it ignites and sets off a chain reaction. The tiny explosion it creates is what lights the gunpowder. Speaking of gunpowder, this is the propellant that resides inside the casing. Once ignited by the primer, the gunpowder burns rapidly, generating a large volume of gas. This gas expands, building up immense pressure inside the casing. It's this pressure that propels the bullet or the projectile out of the gun at high speed. Finally, at the front, we have the actual bullet or projectile. This is the part that travels down the gun barrel and towards the target when fired. The design of the projectile can vary greatly depending on its intended use. From pointed aerodynamic bullets designed for long-range accuracy, to hollow-point bullets designed to expand upon impact, maximizing damage. Each part plays a critical role in the bullet's functionality, as we'll see next. Starting from the outside, the casing or shell is the bullet's container. It's the part of the bullet that you actually see. This humble component has a crucial role. It houses the other essential parts of the bullet. The casing is a bit like a tiny metallic suitcase, protecting its precious cargo until the moment of ignition. Now, what's this casing made of? Usually you're looking at brass or steel. Brass is the more traditional choice, known for its durability and corrosion resistance. Steel, on the other hand, often comes into play when cost-effectiveness is a priority. It's less expensive than brass, but still gets the job done. The casing's job doesn't end there. When the gun is fired, the casing also helps direct the explosive force of the primer and gunpowder, pushing the projectile down the barrel and towards its target. Quite an impressive feat for such a small piece, wouldn't you say? Now that we know about the casing, let's uncover what it holds inside. Next, at the base of the casing, you will find the primer. This small yet integral part of a bullet plays a crucial role in the firing process. Here's how. When the firearm's firing pin strikes the primer, it ignites. This ignition is what sets the whole process in motion. Now, what's in this primer that allows it to ignite? Well, the primer is made up of a unique chemical compound. This compound typically includes lead styphnate, barium nitrate, and antimony sulfide. When struck by the firing pin, the force causes these chemicals to react, creating a spark. This spark is all it takes to light the fuse, so to speak. It's fascinating, isn't it? A simple strike in the right place and boom, the bullet is on its way. This is the power of the primer, the unsung hero in the anatomy of a bullet. As the primer ignites, we move on to the next key component, the gunpowder. Following the primer's ignition, the gunpowder takes the stage. Let's dive deep into the heart of the action. The primer's spark sets off a chain of events that culminates in the bullet's exit from the barrel. This chain reaction is initiated by the ignition of the gunpowder. Now, what's intriguing about gunpowder, or as it's also known, black powder, is its role as the propellant. When the primer is struck, it lets off a spark. This spark, although small, is mighty enough to ignite the gunpowder packed within the cartridge. The moment the gunpowder catches fire, it begins to burn at an incredibly rapid pace. This isn't your average fire. It's a controlled burn, one that's designed to generate a substantial amount of gas and heat. This sudden and swift burning of gunpowder creates high-pressure gas. Imagine the amount of pressure building up inside the confined space of the bullet casing. It's like a volcano waiting to erupt, and erupt it does. the pressure becomes so immense that it forces the bullet lodged at the end of the casing to be thrust out with great force. This is where the magic happens. The bullet, driven by the high-pressure gas, propels out of the casing and races down the gun barrel. Every bit of the gunpowder's energy is harnessed to propel the bullet. The energy conversion is almost perfect, from the chemical energy in the gunpowder to the kinetic energy of the speeding bullet. So in essence, the gunpowder serves as the driving force, the engine, that powers the bullet's journey. It takes the baton from the primer and sprints towards the finish line, pushing the bullet ahead of it. In the grand scheme of things, the gunpowder plays a critical role. Without it, we wouldn't have the propulsion necessary to send the bullet on its intended trajectory. With the gunpowder ignited and the bullet on its way, we come to the final part, the projectile. Finally, we reach the projectile, or as most people call it, the bullet. The bullet, the actual part of the total package that is sent flying towards the target, has a journey of its own. It's a story of pressure, precision, and speed. Once the primer ignites the gunpowder, it creates a high-pressure gas. This gas doesn't have anywhere to go in the confined space of the casing, so it pushes the bullet out, starting its flight. Imagine a cork popping out of a champagne bottle. The pressure builds up until it forces the cork to fly off. That's pretty much what happens with the bullet. But instead of a cork, we have a carefully designed projectile. And instead of a champagne bottle, we have a casing and barrel. As the bullet is sent off, it travels down the barrel of the gun. This isn't just a straight shot though. The inside of the barrel, known as the bore, has spiral grooves cut into it. This is called rifling. These grooves make the bullet spin as it travels down the barrel, stabilizing it and increasing its accuracy once it leaves the muzzle and heads towards the target. Now, there are different types of bullets, or projectiles, each designed for a specific purpose. Some are made to expand upon impact, creating a larger wound channel. These are often used for hunting or self-defense. Others are designed to pierce armor or to stay intact when they hit a hard target. There are even bullets designed to fragment upon impact, creating multiple wound channels. Regardless of the type, each bullet has a job to do, and that job doesn't end until it hits the target. This entire process, from the ignition of the gunpowder to the bullet's flight, happens in a fraction of a second. But understanding the journey gives us a greater appreciation for the engineering marvel that is a bullet. After the projectile leaves the barrel, the bullet has successfully completed its job. So we've taken a journey through a bullet from casing to projectile. We kicked off with the intrigue surrounding bullets, exploring the fascination that surrounds these tiny yet potent objects. We then delved into the anatomy of a bullet, dissecting its design and understanding the role of each part. We examined the bullet's casing, that metal jacket housing all the vital components. We learned how it not only protects the bullet's contents but also plays an integral role in the bullet's trajectory post-firing. We then turned our attention to the primer, that tiny yet powerful spark plug at the base of the casing. We discovered how a strike from the firearms firing pin ignites the primer, setting off the chain reaction that propels the bullet forward. Next, we explored the role of the gunpowder. We learned that the ignited primer's spark sets the gunpowder ablaze, creating a high-pressure gas that pushes the bullet out of the casing and down the gun barrel. Finally, we watched as the projectile took flight, understanding how the bullet's shape and weight affect its trajectory and impact. Each component we've discussed, from the casing to the gunpowder to the projectile, plays a crucial role in a bullet's functionality. They come together to create a harmonious yet powerful symphony of physics, chemistry, and engineering. Next time you see a bullet, you'll know the fascinating journey it's designed to undertake from casing to target.